Well, in this section, we're going to talk about various circle theorems in Euclidean geometry. And before I start, just want to apologize. My printer's running out of ink. I will replace that ink as soon as possible. All right, well, before we get to the circle theorems, we'll just note that there are several important angles that are associated with a circle. And two of the most important we'll look at right now, a central angle and an inscribed angle. And let's identify those. The central angle, or acentral angle, is formed by any two radii of the circle, two radiuses, if you will. And the vertex of each one of those central angles will be the center O of the circle, will be the point O. So just as an example, here's a circle. I put a dot in close enough to the center, I think, as close as I could get by my eyes. And then let's do one radius that way. We'll call this point, say, E, right there. And then we'll put F down here somewhere. I just chose those letters randomly. So that's the center O. This angle is our central angle, right here. So remember, in a circle, let me write this down as the angle EOF. In any central angle, this is going to be the center point of the circle, that O. Now, it says here, identify the major and minor arcs. We briefly spoke about this in an earlier video. The minor arc that is intercepted by this central angle is this right here. This is the arc intercepted by the point E and the point F on the circle. So this would be called the minor arc, and we would write it as EF, kind of with a nice arc over it like that. The major arc is kind of the other part of the circle. Let me use maybe this pencil. The major arc would be this part of it. Major arc. We would call it the same thing, so you have to note whether you're talking about the major arc or the minor arc, but unless otherwise stated, we're always talking about the minor arc, the smaller of the two. The minor arc is the one that would be less than 180 degrees. This would be greater than 180 degrees. So if we don't say which one we're talking about, we mean the minor arc, the smaller of the two. Okay, remember from a previous video also, what is the measure of the arc, EF? By definition, the measure of arc EF, we're talking about the minor arc, is equal to the measure of the central angle. The central angle that intercepts this arc. So the measure of arc EF is equal to the measure of angle EOF. Or I could have said FOE, but just make sure that O, since it's a central angle, the center O has to be the vertex, the middle value of this angle. Okay, that's the central angle. And now let's look at an inscribed angle. An inscribed angle, basically you just take any 3 points you want on the circle and create an angle out of them. So actually, if you put 3 points on the circle, let me put some points here. Let me put an L there, maybe put an M here, and N here. I could create actually 3 angles out of that, depending on which one of the 3 I want to be the vertex of the angle. I will look for angle, how about LMN? So M is going to be the vertex. So that means just connect L with M and M with N. And we have an inscribed angle. So an inscribed angle is formed by any two chords that meet at a common point on the circle C. So remember, let me write down the circle. Circle C is the whole circle. I'll just draw an arrow to it. And remember what a chord is. A chord is what you get when you take any 2 points on the circle and you draw a line segment to them. So this is 2 chords, and they meet at a common point. In this case, it's the common point M. So that's an inscribed angle. And there is an intercepted arc from this angle. I won't draw it, but it would be this right here. The angle is LMN. This would be the intercepted arc. Maybe I'll draw it lightly. Right there. Okay, now just as a note, since we've got both of these diagrams here, what is the measure of this intercepted arc right here? The measure of arc, what would this be called? LN. How do you get that in degrees? Well, it's not the same as this angle because LMN is not a central angle. It would be this angle. We'll call that O, the center. Draw that line segment and that line segment, giving us this angle right here. That would be the measure of this arc. It's the measure of the central angle that the measure, let me rephrase it here. The minor arc is the measure of the intercepted central angle. So the measure of this angle, which would be measure of angle, LON. Okay, so we've got central angle, which remember, the vertex is the center of the circle O. An inscribed angle, you just get 3 points on the circle and pick one of them as being the vertex of that angle. 2 line segments are 2 chords that meet at a common point. Okay, now we've got one limit to look at, and we'll be done with this video, called half arc measure. We have a circle here. I already drew as close as I could the center, and let's see what this lemma says. Let angle ABD be an inscribed angle. So A, B, and D are going to be 3 distinct points on the circle C. And the center of the circle is going to be O, the point O. So I'll label that as O. If one of the sides of angle ABD contains O, the origin, then the measure of angle ABD is, and I'll do this in just a few seconds, the main measure of angle ABD. Well, notice it says if one of the sides of angle ABD. So that means it's either going to be BA or BD, because B is the vertex. So I just chose BD. If I would have chosen BA, this proof and the theorem would be exactly the same. Just replace A with D, D with A in this picture and in this proof. So we're just going to assume, I'll just make a note here. Assume O, let me say BD line segment contains the center O. All right, so that's how I've got it drawn here. Okay, so we need the angle, so we need to finish this. Okay, now we have the angle ABD. Well, what do you think the measure of angle ABD might be? Well, since we're using O, let's draw this line segment from O to A like that, since we need it. Now you can tell just by inspection which angle is greater, AOD, this one right here, or ABD, this angle right here. You can tell that this one is bigger than this angle. And then also remember that the measure of this angle is equal to the measure of this arc. That's just by definition. Okay? So it turns out that if you've got this inscribed angle where one of the sides of the angles contains the center, by the way, what does that mean? That means that BD is a diameter of the circle. Okay? All right. The measure of angle ABD is equal to 1/2 the measure of this arc. The measure of arc AD. And what did I just say a minute ago? We've said this several times. What is the measure of arc AD? By definition, the measure of that arc is the measure of angle AOD, the central angle that intercepts that arc. So maybe I'll go ahead and write it down this way. We know that equal, by definition, the measure of angle AOD. And that's the statement. All right, now we are going to prove that that's true. All right, let's go through this proof. Pretty short. We'll just complete it. We're basically going to fill in some blanks. All right, now draw the radius OA, which we did already, OA, and observe that OA is equal to OB. Remember what this means? The distance from O to A, or the measure of line segment OA, is equal to the distance from O to B. Why is that true? I didn't write the reason because we've done this so many times. They are both radii of the same circle. So if they're both radii of the same circle, we know they have the same length, OA and OB. And also OD, also. If I wanted to put a dash there. They're all radii of the same circle, so they have the same length. Label the measure of angle ABD, and notice that ABD is the same as ABO as far as the angle goes. The measure of angle ABD, will mark that as X. All right, so that's that angle, X degrees. Okay, ABD. All right, well, what does that tell us? What does this tell us about triangle AOB? If it has two sides that are equal length, AOB, this triangle, two equal sides, that means it's an isosceles triangle. So triangle AOB is isosceles. And what do we know about the measure of angle OBA? What is it equal to? Well, X, but it's also, since these are the two equal sides, the two angles opposite them are also equal to each other or have the same measure. So measure of angle OBA is equal to the measure of angle OAB. That's because it's an isosceles triangle. So that means I can call this X as well, that angle. Angle X, angle X. Well, do you remember this theorem called the Euclidean exterior angle theorem? Since angle AOD is an exterior angle to this triangle AOB, remember what to get an exterior angle, you just extend one of the sides of the triangle, extend this one, and that gives us a new angle right here. And in the Euclidean exterior angle theorem, we know that the measure of this angle is equal to the sum of the two opposite interior angles. So let me write this out. The measure of angle AOD, this one right here, is equal to the measure of angle ABO plus the measure of angle ABO BAO. Okay, let's see. The measure of angle ABO, that's this angle, plus the measure of angle BAO, which is that angle. Well, both of those angles have measure x. That's equal to x plus x, or in other words, 2x. So what does that tell us? Let's draw that in the picture here. That's 2x. So how do these two angles compare? This angle and this angle. Well, you can see this one's twice as big. Or in other words, this one is half the measure of this one. So the measure of angle ABD is equal to 1/2 the measure of angle AOD. And that's really what we were trying to prove, 1/2 the measure of angle AOD. I'll go ahead and make a note that that's equal to the measure of this. This angle is equal to the measure of this arc. So 1/2 the measure of the central angle is 1/2 the measure of arc AD. So once again, in summary, we showed that when you have an inscribed angle where one of the sides of the angle passes through the origin, which means one of the sides is a diameter of the circle, the measure of that angle is 1/2 of the measure of its intercepted arc. Its intercepted arc is equal to, the measure of the intercepted arc is equal to this central angle right here.